Every day, our innate immune response protects us from cancer and infectious diseases. It's essential for our existence and is so fundamental to life that we share much of it with primitive animals such as sponges and earthworms. Adaptive immunity evolved more recently, but to be initiated, it still needs the innate immune response. Within our innate immune system, natural killer cells, or NK cells, are the major cytotoxic lymphocytes. They circulate in our blood and reside in lymph nodes and our lymphoid organs like the liver and the spleen. NK cells constantly patrol our bodies to eradicate cancer cells as they arise and provide crosstalk to the adaptive immune system. This surveillance by NK cells in healthy individuals provides a rapid response to tumour formation and is vital for the early reaction to tumorigenesis, independent of T-cell immunity. So understanding tumour-specific NK cell responses is essential to maximise their therapeutic potential in cancer treatment. As resting NK cells circulate, their activation is controlled by a multi-step process requiring binding of signalling molecules on their surface by molecules expressed on tumour cells. When NK bind to cancer cells, they form a tight bond called an immune synapse, where the tumour ligands attach to their specific NK cell receptors and initiate a cascade of signals. This moves the NK cells from resting state to the point where they can kill the cancer cell. Most tumour cells provide enough of these signalling molecules to trigger NK cell killing. But tumours can evolve, and any genetic changes which lead to loss of NK activating molecules will protect them from lysis. Here you can see human NK cells interacting with and binding to ovarian cancer cells but failing to kill them. The immune synapse forms, but the absence of some of the key cancer signaling ligands prevents full activation and triggering of the NK cells. These NK-resistant cells evade NK cell killing and become more prevalent. A growing tumour ignored by these NK cells can lead to the development of cancer. Immunotherapy can overcome this resistance by providing NK cells with the additional signaling ligands which the cancer cells have lost. We've created IncMune. IncMune is a suspension of specialized inert tumour cells which are delivered intravenously. The IncMune cells circulate in the blood where they bind to resting NK cells. IncMune cells express hundreds of thousands of molecules which stimulate resting NK cells to the point where they no longer need the activating ligands which are missing from the resistant cancer cells. IncMune cells bind to NK cells via multiple different receptors, one of which is CD15. In the cell synapse, CD16 is shed from the NK cell surface, and CD3 zeta is released to bind to the intracellular domain of CD2. The CD2 receptor on the NK cell binds to CD15 on the IncMune cell, causing sequential phosphorylation of CD3 zeta, LAT, and STAT5, and leading to gamma interferon synthesis and NK activation. The primed NK cell now needs to bind fewer activating ligands on the tumour cell to be able to kill it. So cancer cells which had evaded NK cells through loss of signaling ligands are now susceptible to these primed NK cells and are killed. Here you can see IncMune primed NK cells killing the NK-resistant ovarian cancer cells which they failed to kill before. The primed NK cells form very strong bonds to the cancer cells and then induce lysis.